Okay. My second section about moment is how can I find the sum of the moment of a set of forces acting on a body. Sometimes you will have a number of moments acting around a single point, so you need to calculate each one of the forces individually, and then you add the forces together, which will give you the magnitude and the direction of the movement. Now, if I want to find the forces around P, again, imagine you put your finger around P and you push each one towards P, each one of the forces towards P, and you will check by yourself whether it's going to move in an anti-clockwise or clockwise direction. To start, let's say with 5, again it will move in this direction, which is clockwise. While if I want to look at 3, it will be going again upward but towards P again, so it will go in this direction. While if I want to check the one which is 4 Newton, which is acting downward, again if I want to find it around P or towards P, it will be going in an anti-clockwise direction. So you will be seeing in here that the 4 and the 3 are both acting in an anti-clockwise direction, but the 5 is acting in a clockwise direction with respect to P. And in this case, if I want to calculate the moment about P, I start with 1, which is 5, second force, which is 4, and the third, which is the 3 Newton. You multiply 5 by 3, which is 5 by how far is this 5 away from P. You will find it to be 15 Newton. 4 is away 1 meter from P, so it's 4 Newton meter anti-clockwise as we agreed for, and the 3, again it's away 1 meter from P, which is anti-clockwise. Again, choosing clockwise as the positive direction, you can choose the anti-clockwise as I told you. The only difference is that you will be getting the negative a negative answer. Okay. Now, if in this box you will see this remark, if you have chosen anti-clockwise as the positive direction, our answer would have been minus 8 Newton meter anti-clockwise. So I just choose a clockwise to be my positive direction to avoid the negative answer. Another question, if I have these two forces and I want to find their moment with respect to P, again, this force will be acting with respect to P. You have this force anti-clockwise while this force will be moving clockwise. Again, you start by the first one, which is number 1, the first 5. It will be 5 times 2 equal 10 Newton meter in a clockwise direction. The second force, which is 5, multiplied by 4, which is 20 in an anti-clockwise. So since in here 20 is more than 10, I will choose my positive direction to be clockwise, and I will be getting the sum of the moments acting about P will be equal to 10 Newton meter. Okay, hopefully it gives you an idea about how do we find. We will continue our chapter about moments, and we reach the third section in this chapter, which is equilibrium. You should know that when a rigid body is in equilibrium, it means the resultant force in any direction is 0. And the moment about any point on the object will also sum up to 0. If I have this plank over here and I want to find the moment of the force around about y, I have two forces acting in this plank. The first one is 10 Newton, and if I want to push it with respect to y, it will be in a clockwise direction, while the second one, it will be in an anti-clockwise direction, and they are both away 4 meters from y. So let's find the sum of the moment acting about the point y. We will start with each moment separately. The first one, which is 10 Newton, and the moment will be 10 times 4, which is 40 Newton clockwise. While the second one, it's as well 10 times 4 equal 40, but in an anti-clockwise direction. As the moments are equal in both directions, the rod will not turn, and hence it will be in equilibrium. And as the road is fixed at y, it will not be lifted up by the forces either. Let's check another question. Again, in here we have two forces. If I want to find the sum of the moment acting about the point z, I start with the first force again, which is 3 Newton, and it will be acting in an clockwise direction with respect to z, while the second one, which is 1 Newton, will be acting in an anti-clockwise direction with respect to z. Let's calculate each moment separately. You will be having number 1, which is 3, and it's away 2 meters from z, so it's 3 times 2, which is 6 Newton meter in a clockwise direction, while the second one, it will be 1, and it's away 6 meters from z, so the answer will be as well 6 Newton meter in an anti-clockwise direction. As the moments are equal in both directions, then the road will not turn and hence is in equilibrium.